and chapters 3, and we just did chapters 3. Chapters 4, 5, and 6 are all trig. Chapter 7 we don't do. Chapter 8 is conics. This is chapter 9. Chapter 10 we don't do. So there you go. That's why we go to chapter 9. I explained this in second hour, and then at the end of the hour someone asked me that same question. So we'll see if that happens in here as well. There's a little bit of writing today, but it's really not so terrible today. It's kind of somewhat of a review from last year. SAT questions, they always give you questions that use the fundamental counting principle, and I feel like the book makes it really complicated with all these words. But did you ever see a question on the SAT or the PSAT that says, you have 4 shirts and 3 pair of pants and 4 pairs of shoes. How many outfits can you make? Right? Remember those questions? Quick price, so yeah. Let's see if everyone else has questions. It's really cold in 2 minutes. Yes. Yes. I was just checking. Yes. I really am hoping to squeeze in 9-2, day 2, and test corrections, but we'll see how it goes. Maybe, yes. We'll see how it goes. I'm really kind of stressed about getting this chapter in, and so we'll see. 9-2, day 2 homework is really short if it makes it any better, but we'll see. We'll see how it goes. That's tentatively scheduled. We're definitely doing test corrections, but we'll see how 9-2, day 1 goes. So I may be convinced that we'll just, I don't know what we'll do. But the fundamental counting principle basically says if you have 2 things that can happen in so many ways, and they call them M1 ways and M2 ways, to find the number of ways that they can happen, is you just multiply them, right? So if you have 3 pair of shirts, you don't say that. If you have 3 shirts and 4 pair of pants, and you want to know how many outfits you can make, if you don't care if they match or not, you just multiply those together. So a lot of your homework is you just get to multiply things together, and you don't have to overthink it. Back in Algebra 2, and maybe even before that, you used to make those like tree diagrams, right? Like if you're like, I have 2 types of bread, white bread or wheat bread, they both start with W. White bread or, what other kind of bread can you have? Raisin bread. Who has raisin bread? And then you have like 3 types of meat, ham or turkey or roast beef. And then you have 2 types of cheese, right? You remember you do all that and then you count up. Well, that's ridiculous. You don't have to make tree diagrams. You could. You can just multiply them together. So that's a key idea today. So then I could give you questions like this, and you can kind of shorten this up a little bit if you want. But how many different license plates are possible if each license plate has 3 letters followed by 2 digits? We can use the fundamental counting principle to do these kinds of questions. Enjoyed your answer on your test there, about what is the logarithm. Yeah. I may have wrote you a note.
There was a rest like that for you?
What was that? For your life.
See? How was that?
Drives me crazy, you know that, right? Because you could get an A on the test if you just did your homework.
I think we could do it, you know what?
And that really drives me crazy. But, yeah. What is an exponent? Benjamin wrote, and then he erased, but a useless piece of information, or something like that is what he... What is a logarithm? I mean, sorry.
What is a logarithm?
Oh, some people haven't taken the test yet, so...
How many
A useless piece of information is what Benjamin wrote. And then he erased it, but then he didn't erase it well enough that I couldn't still read it, so... When we do problems like this, I like to just draw out little, like, there are 3 letters, so I like to draw 3 letters. 3 letters followed by 2 digits. And I need to figure out how many are possible for each one, and then I'm going to use the fundamental counting principle just going to always multiply those together. Right? No trickiness, no eating, no lning, no graphing. But you do have to know how many letters are in the alphabet. 26. Does it say that they can't repeat themselves? It doesn't say, so that means we're assuming that they can repeat themselves, because if they can't, then it would tell us that. So do you agree that I could have 26 in each one of these? 26 times 26 times 26? Followed by 2 digits. How many digits do we have? 10, because you have to count 0. Some people think 9, but don't forget 0 is also a digit. Base 10 number system. So followed by 10 and 10. If it said they couldn't repeat themselves, then you'd have to do 26, 25, 24, 10 and 9. But then we just multiply that together, which I think is a really big number. Bryce, what did you get? Like it's over 1 million, right? I'm just going with your answer. Unless somebody disagrees. Yeah. Trevor disagrees. Oh, Bryce, check again. How many digits are possible? 10, right? What did you do? 9. 9. Yes. That'll change it. 0 is also an option. What if it said each space could be a number or a letter? What would you put on each one of these? 36, right? I'm trying to kind of get you towards your homework today. Yes. How did we get the 10? Because digits, right? Think about our digits. You could have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you agree that those are the only single digits that we have? So lots of people like to say 9 because they think that we only have 1 through 9. But 0 is also a digit. And another way to think about it is think about common log. We're base 10 number system. We're called base 10 because we have 10 digits. Okay? Okay. So some other things that we can look at besides just multiplying things together, which a lot of your homework is just multiplying different options. But we can also talk about permutations. And permutations are when you arrange items in order, or when order matters. That's what I like to think about it. And so my example here is if you're talking about giving out first prize, second prize, third prize, it matters the order. If I got first prize and Ben got second prize and Nate got third prize, that's different than if he got first, he got second, and I got third. Or he got first, I got second, third, right? And those are different combinations. So if order matters, it's a permutation. This is like the last chapter that you did in Algebra 2 last year, I think. Any big memories of this? Permutations, combinations, probability. So sometimes you're doing a permutation and you don't even think about it. So like this problem. If I said, how many ways can 5 people line up? Again, I like to make my little spots just like the license plate. 5 people. How many people could get first in line? 5. But then you got your line leader. So how many people are left to be second in line? 4. And then you only have 3. And then you only have 2. And then at the very end, there's only 1 person left, right? Or we could say 5! Right? See if you're awake today, Bryce. What is that called again? Not yelling 5, really. My voice is really, my throat's kind of not so good, so I couldn't really yell as loud as I normally yell. Factorial. 5 factorial. We don't really just scream 5, but it's my favorite thing to do. And there's a button on your calculator for factorials, right? So if you recognize that, you can always just do factorial. On my calculators, it's under the probability button, which is PRB. If you hit 5 and then you hit PRB and you scroll over, there's a little factorial button, and you can just type that in, and you get 120. So we can say that there will always be in factorial ways that in elements can be ordered. That always works. How many ways can I put 10 books on a bookshelf? How many ways can I pick 7 classes? It's always factorial if you're using all of them. PRB, got that button?
Yeah.
So hit do 5 and then hit PRB, and then mine's the third one over. So you like use your arrow over to get that exclamation point and hit enter and then hit enter again. See if that works. Does that work?
Yeah.
How does 0 factorial 1? Yeah, it's like,
I know, it's kind of mind-boggling. I don't know.
there's only one way to be 0?
I think about it when it comes to these formulas. Hold on, and we'll get to the formula and I'll show you why. Because that's like, we looked it up. There's some, I forget what class someone asked me. Maybe Scott asked me that question.
I guess 0 raised.
0 raised to the 0 power is undefined, actually. Like, if you try to do 0 to the 0 power, it's an error. It's not defined. Because math, like, it conflicts with itself. So, it's not defined. It's not defined because 0 to the first power is 0, 0 to the second power is 0, 0 to the third power is 0. So looking at that, you would think 0 to the 0 power should equal 0, right? But then think about anything to the 0 power. 3 to the 0 power is 1, 2 to the 0 power is 1, 1 to the 0 power is 1. So then you would think 0 to the 0 power should equal 1. So because those conflict with each other, it's just not defined. Well, that's our math conundrum. And they just say, it doesn't fit with either one, so not defined. That's neither here nor there. Yeah, you can't do 0 to 0 power. So what about this problem? It says if you have 6 books with room for only 3 on a shelf, how many ways are possible for you to put 3 books from your 6 books on a shelf? Now this is not 6 factorial because I'm not using all 6 books. You agree with me on that? If I was going to say how many ways can I put 6 books on a shelf, I would just say 6 factorial. But I only have room for 3 of them. So I only got 3 spots. How many books can go in the first spot? Then how many books can go in the second spot? Then how many books can go in the third spot? And then I stop, right? Because I don't have any more spots. I think that happens to work out to be 120 also. Not every answer is 120. It just happens to be these 2 answers. And if you remember anything from last year, there was a formula of how you could do this. You could say this is a permutation where you have 6 and you're choosing 3 of them. And there's a button on your calculator for that as well. Here we go. The number of permutations of n elements taken r at a time is given by this lovely formula. And these both mean the same thing. They're just 2 different ways of writing it. Most of the time, you're going to just want to use the button on your calculator. But there are a couple on your homework, and there are a couple on your test that I say, show me the formula. Like, I want to know that you know how to use the formula. And Bryce, this comes back to your question of why is 0 factorial 1? So let's do this problem up there first, and then I'll do a problem with 0 factorial to see if it sort of makes sense of why 0 factorial is 1. I looked up a reasoning for it on the internet, and that's the only reason I got. Like, I didn't get any big math proof. I just got, well, because this has to be true. And I was like, huh, that's true. So, the same problem up there. We had 6 books. We're going to choose 3 of them. And order does matter here, because if I have Goldilocks and the 3 Bears, and then I have, I don't know, the 3 Little Pigs, and then I have, I don't even know, another book, Beauty and the Beast, it matters which one's in which spot, so order matters. You can tell what kind of book I read, not Beauty and the Beast, but kid books. You would take the bigger number, which is 6 factorial, over subtracting them, 6 minus minus 3 factorial. And on your calculator, under that probability button, is a button that says, like, NPR, and you can hit 6, you can hit that button, you can hit 3, and it'll give you the answer. And that's a great button. We're going to use it at times. But you also are going to be expected to be able to do this and show me the formula. And then you can still use your calculator to help you, but this would be 3 factorial left on the bottom, and we'd still get 120 as your answer, the same answer that we got up there. What about, Bryce, if I had one item and I want to order it, like if I have one book and I want to put it on the shelf, how many ways could I put one book on the shelf? One way, right? So think about if you used it in this formula. You would have 1 factorial over 1 minus 1 factorial. So you'd have 1 factorial over 0 factorial. If 0 factorial was 0, we'd have a big problem here. It's just 1 over 1. I don't know if that justifies why it's 1, but it makes this formula not work if it's 0. Nothing? I don't know. All right. So do this one without your calculator first. Well, I mean, you can use your calculator to multiply, but don't use the permutation button. And then check it with the permutation button. Because I want you to be able to do both. There are 2 questions on your test that say, use the formulas to find the permutation or combination. We're going to learn about in a minute. And this is really what I mean when I say that. Like, I don't mean that you have to not use your calculator at all. I just want to know that you know the formula, and then you can use your calculator. You can use the button. I would never know as long as you write this out. But to me, I always feel like I could cross those out. And then I could take 7 times 6 times 5 times 4 times 3. And I got 2,520. Did you get that? I'd also like to, if you haven't messed with the permutation button on your calculator, to try that. Because most of the time, you're going to just use that button. On the homework today, unless it's written like this, where this is the only thing that's written, you get to use that button. There's only 2 questions that I make you actually work it out. If it's a story problem, you get to use that button. So on my calculators, everyone's different, but on my calculators, you'd hit 7, and then you'd go to probability, and mine's the very first one, so you'd hit enter, but then it shows NPR, and then you hit 5, and you just hit enter, and it should give you 2,520. So again, you want to make sure you know how to use the calculator that you'll use on your test, because I will help you learn how to use it up until the test, but during the test, I will keep punching buttons in your calculator for you. Okay. A couple other little formulas that we have. It's kind of a lot of writing, but what if you take an object and it repeats itself? So it says, suppose a set of in objects has in one of one kind of an object and in 2 of another. Kind of looks really crazy. So mostly this has to do with words. What if you have a word that repeats itself? The letters repeat themselves. Just like they said that people learned this last year, second. And remember, like the question would be like, how many ways can you rearrange the letters in the word banana? Remember that question? But that's the formula we're going to talk about. I'll just show you this. We call this the formula for distinguishable permutations. You cannot use the button on your calculator. It does not give you distinguishable permutations. I love this test. Lots of formulas. I don't know. I should have really guessed right, right? telling Ben on Friday when he turned his test in, like, it's the only one this year that I count how many problems he did instead of how many problems he didn't do or something, because it's weird to count how many problems. He was much better this time. And your test grade was much better, so you know, it seems to me like there's somewhat of a correlation.
No, it seems to me that
For most
I also stick away for least. I'm not as tired.
So here's the formula. This is your total number of letters, or I guess total number of objects, but I feel like our problems are always about words, so it's like the total number. And then your bottom numbers are the number of letters, the number of times each letter repeats itself. For me, I only do the ones that repeat itself more than once, because if it repeats itself only once, 1 factorial is just 1. So I'm going to put that the bottom is each object, the number of times it repeats. And you just got to remember that this has its own special formula. So when they give you a problem like this, how many different ways can the letters in Indiana be written, that you remember you have its own special formula. And then you just take the total number of letters factorial on the top, divided by the number of times it repeats itself on the bottom. Oh, I was grading tests last night, and I felt so bad for your first part, because you worked that one out that was like the 8th power or something ridiculous. You didn't have to work all that out. Like, I felt terrible.
I know, I forgot.
Like, you could have just left it with that power, though. Like, you had the right answer. And you just didn't have to multiply it all out. You know what I'm saying? And I felt so bad. Your paper was a big giant mess as you multiplying things out without a calculator. And I was like, oh, I feel so awful. Parker was helping me put grades on the top of them yesterday, and I said, see if you can find somewhere to write this grade, because your paper was so full of stuff. I was like, there's not much room on it. So Indiana has 1, 2, 3, 4, 5, 6, 7. So that's 7 factorial on the top. And on the bottom, you're just going to take each letter the number of times it repeats. So there are 2 I's, so I'm going to divide by 2 factorial. The reason that you have to do this is if we're trying to make distinguishable permutations, we say words, and like the book says how many words in quotation marks. We're not really making words, we're just rearranging letters. But if you replace this I with this I, do you agree that that's the same word, like nothing's changed? So that's why we're dividing out the ones that repeat themselves. So it repeats itself 2 times, so I can also divide by that twice, 2 factorial, I guess. And A repeats itself twice, so I can divide by that. You don't have to put 1 factorial down there for the D, you can, but it's just 1, so I never include that. Vague memories of this from last year? And you just work it out. You can use your calculator, but just be like, on the bottom, I would just divide that by 8, because I know 2 times 2 times 2 is 8. Otherwise, you need to put parentheses around that. Like if you just do 7 factorial divided by 2 factorial times 2 factorial, you're going to get the wrong answer. Sometimes I like to do it without a calculator because I like to show you that your life isn't dependent on a calculator. Because I could cross out the 2 and the 1. 2 times 2 is 4. That's still kind of a really big number. How much is it? Did anybody do this yet? 630. I didn't erase it earlier. 630 different combinations of letters. These would not all be words. Your book uses words in quotation marks, but that doesn't mean you're really finding how many words you could make. There's not going to be many other words to make out of the word Indiana where you use all of them, right? You okay with that? So we have one other thing. Permutations are when order matters. If order is not important, like pizza toppings, or like if I said I'm going to pick a group of 4 of you to work together, it doesn't matter what order I picked you for, you're just all in one group. Pizza toppings don't matter. Like sometimes you go to a restaurant, they'll say, like Subway says, there's so many combinations of sandwiches you can make. That's because they're doing a combination. How many ways can you order a pizza if you have this many toppings and this many types of crust? That is, of order is not important. And that is called a combination. Combinations are used a lot more in probability than permutations because oftentimes in probability, order does not matter. So part of your homework today, you don't even have to work them out. They just give you some scenarios and you have to say, is it a combination or is it a permutation? Does order matter or does order not matter? And notice I have another formula, and you probably already found next to your permutation button on your calculator is there's a combination button that you can also use your calculator for. Notice the combination and permutation formulas are very similar. You both take the total number factorial over n minus r factorial, but you also divide by r factorial. So your combination numbers are going to be smaller because you're dividing out more. If order is not important, there's less options. So again, I do want you to know the formula. If I gave you a problem like this, I want to see that you can plug it in the formula. And then on the other problems, you can just use your calculator. Only one of those. I think these are my last two examples. We're going to be down to like 2 o'clock. So this is like 10 to 6. So I'm going to take 10 factorial over 6 factorial and 10 minus 6 factorial. And again, these numbers are going to be pretty small. I can do this without a calculator because a whole lot of stuff's going to cancel out. 10 minus 6 is 4. So again, I could cross out everything from 6 down because 6 factorial is on the top and the bottom. And then I like to cross other things out. 4 times 2 is 8, so I could cross that 8 out. And 3 divides into 9 3 times. So 3 times 7 is 21 times 10. I think the answer is 210. Did you get that? Probably by just typing in your calculator. Which I'm okay with. I just like to show you it's not always required. Problem like this on your homework, you're going to show me some work. You don't have to show me all that work. But if I gave you a problem like this, you don't have to show work. You can use the button on your calculator because I do want you to know how to do that. It says, out of 12 pizza toppings, how many ways can you choose 2? Right? Like you could choose sausage and pepperoni. You could choose sausage and mushroom. You could choose onion and green peppers. Right? Instead of actually going through and thinking of all the combinations, order does not matter. It doesn't matter whether you order sausage and pepperoni or pepperoni and sausage. It's the same pizza. So that's where you would just do 12 choose 2, and you can type that in your calculator. On your homework today, some of the problems, the difficult part is it a permutation, is it a combination? Does order matter? Does order not matter? Once you figure that out, you can just type that in your calculator. And again, on my calculator, you hit 12 first, you go to probability, and you find that button, and then you hit 2. And has anybody done that? 66? 66. A lot of your homework today is just multiplying. So it's not a combination or a permutation. If we're talking about license plates, if we're talking about clothes, if we're talking about something where you can just say, oh, there's 3 of these, there's 2 of these, I'm just going to multiply those together. You're just going to multiply. All right, I'm not going to be here tomorrow, so I want to make sure that you get started on your homework now so you can get some help on it if you need it. But I also am going to record going over some homework questions, some ones that I know people have trouble on. And then I'm leaving you notes for tomorrow. So come in. The sub will start the video, have your homework out so you can get homework questions answered, and we'll take new notes. And then on Wednesday, we're for sure doing test corrections, and then we'll see what else we can maybe squeeze in there. Okay? So, here's your homework. I have a homework sheet for you as well. Notice up here, 15 and 18, I want you to actually use the formula. Everything else, you don't have to use the formula. A lot of people were like in the 30s before they left here in second hour. So get your book out and get started on it so you can get